Hello, in this video we'll be doing a little bit more about inverse functions and their graphs. Last video we talked informally about what an inverse function was. In this video we're going to take a look at the definition of inverse functions. That means that if f and f inverse are inverse functions, then this evaluation, if we evaluate f inverse inside of f, or if we involve f inverse inside of, f inside of f inverse, both of those evaluations will give us x. The best way to do this would be to split the definition into two parts. Is first of all plug in the inverse into the function and see that we get x, and then plug the function into the inverse and see that we get x. If this happens, then those two functions are inverses. So that means when we're evaluating these functions, we start with an x value here. So we start with this x value right here, the inside thing. We plug that into f of x. So it goes into f inverse. It becomes this function's inverse x. So it becomes this after we plug it in. And then we plug that into the function f. And that eventually is going to give us this x value right here. That's this first definition. The second definition does the same thing, or similarly. We start with that x value right here. We plug it into f. We get f of x. We take f of x and we plug it into the inverse, f of x into the inverse, and we get the answer x back. So that's what happens when we pass the value through there. We pass the value through, we plug it into the inverse, we get an answer. We plug that answer into the function and we get x, and vice versa. Alright, so we're going to use this definition to show that these two functions, g of x equals 2x plus 6 and g inverse of x equals x minus 6 divided by 2 are inverse functions. So we're going to start with the first definition. We're going to try to show that f, in this case it's g, so we're going to show g inverse of x is equal to what? So what we're going to do here is we're going to plug this function. So we're going to start with this function. We're going to plug that into g. So we're going to take this function x minus 6 divided by 2, and we're going to plug that into g. So that means that we're going to take this function 2 times x plus 6, and we're going to plug that, there we go again with the jumping around a little bit. 2 times this function, x minus 6 over 2, gets plugged into g of x. So we take the inverse function, that's the x minus 6 over 2, and we plug it into the other function for x. We replace it. It gets put into the x value. You don't see two x's here. You see this x being replaced with the inverse function. So if we simplify that, these two things will reduce. Okay, and then we're going to get x minus 6 plus 6, which gives us x, and that gives us half of our definition correctly. Alright, now the second half of the definition, we're going to do g inverse with g of x. We're going to check that to see if that is the value of x. We have to have both of these things occurring in order to get the definition to be true. Alright, we're going to take g of x, which in this case is 2x plus 6, and we're going to put it in here. So we're going to put that 2x plus 6 because that's g of x. We're going to put that in there, and this 2x plus 6 is going to go into g inverse. Well, the inverse is something minus 6 over 2. X minus 6 over 2, but we're going to plug in the other function there. We're going to plug in the 2x plus 6. So evaluating that, we're going to get 2x. These two 6's are going to reduce out. They're going to give us 0. Okay, so we're going to end up with 2x over 2, which then gives us x. So in both cases we did get x both times, and by definition g and g inverse are inverse functions by definition. All right, graphically, let's take a look at the graphs. Graphically, the inverse function changes the point from x, y to y, x. That means it reflects, it changes that thing. It's going to reflect over the line y equals x. And the graph of the inverse function is also going to be reflected over that line y equals x. So what we're going to do is, when we look at the graph, let's look at this graph right here, we're going to change the coordinates. So once we have some of the coordinates, we're going to change those values. So this coordinate right here, let's just start with this one on the left hand side. That coordinate is -2, -3. So in the inverse, we will switch those two values and it would go to -3, -2. So it would end up right here at -3, -2. They get switched or swapped. Okay, let's go to the next point. This is a straight line, so if we can just go to the endpoints of the straight line and look at those, we can map those out and connect them on our inverse. So in this case, this point is 2, -1. So we're going to map that out at -1, 2. So it's going to be mapped out right here at -1, 2. So our inverse function, this function here, if this was f of x, our inverse function is going to run from here through here. We're going to have that function right there. Let's try to make it a little bit less curvy. So we are going to go through here. Oops. This is I thought I was doing so much better with this. Okay, so it looks like we have a slope of, go right here, goes through there, and then it goes through here. So 1, 2, 3, 4, 1, 2, 3, 4, right? So we're going to go from here through there, and that does make sense because it did go through -2 on this axis, so it should go through -2 on that axis. That does make sense. Okay. Now this point right here on this little segment is 3, -1. So that means the inverse is going to be up at -1, 3. So that'll be right here. That'll be -1, 3. So it's going to go straight up through there. And then this endpoint here is 6, 5. 6, 5. So that means we're going to go to 5, 6. So we'll end up right here at 5, 6. So this one's going to travel from here to there. So this is our inverse graph using the relationship that our inverses switch the x's to y's and the y's to x's. Now, it's a reflection over the line y equals x. So if I were to graph in the line y equals x here, let's make it dotted. We'll make it this color dotted. So y equals x would end up going through here, through the corners of the graph. As you can see here, this is a mirror image along this y equals x graph. This is y equals x. So that's graphing the inverse. So in graphing the inverse, we swap the x and y values. Both of these are functions because they pass the vertical line test.